Question number 3 says, from the Venn diagram, this is what we call Venn diagram in set theory. Shade the portions that represents A, P union Q prime, B, P prime union Q prime, C, P intersection Q prime, D, P prime intersection Q prime, E, P prime union Q, F, P intersection Q prime. This is the delight of external examinations. I would like you to pay acute attention because I'm going to take my time to explain how you shade your Venn diagram in these concepts. I'm going to take them one after the other with illustrations. Let's take the first. Question number A. We have P union Q prime. First of all, before you know what to shade, you have to work out this P union Q prime. How do you work it out? You are going to do a sketch. Write up any universal set you know. Write up any set, call it P. Write up any other set, call it Q. Find P union Q and find P union Q prime. From there, the idea of what you should shade in the Venn diagram will come. So let's take numbers from 0 to 10 as our universal set. So let's our universal set be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is very, very important. Now, if you look at the universal set, there is P, there is Q, and there is P intersection Q. This area is called P intersection Q. Now, when you will be choosing the members of your P and your Q, make sure you choose it in such a way that there will be P intersection Q. So let's choose as members of our P, let's choose prime numbers. Prime numbers are 2, 3, 5, and 7. These are prime numbers. Now let's choose for Q. Let's choose factors of 10. Or let's choose factors of 8. Factors of 8. So this one is prime numbers. That is prime number between 0 and 10. Now let's choose factors of 8. Let us write them down first. 1, 2, 4, and 8. Remember, I have carefully chosen now so that there will be P intersection Q. A member of P that is also a member of Q. So these are factors of 8. Okay, now the issue or the set we want to shade is P union Q prime. members of P and members of Q that complements members of the universal. Otherwise, members of the universal set that you could not find in P union Q. That is what we call P union Q prime. So now, first of all, we are going to find P union Q before we can find P union Q prime. So let's find P union Q. P union Q is going to be 1, 2, 3, 4, 5, 7, 8. 1, 2, 3, 4, 5, 7, 8. This is P union Q. Now P union Q prime are those members of the universal that are not found in P union Q. So let's check. 0 is one of it. There's no 0 in P union Q. So write down 0. There is 1 here. There is 1 here. 2, 3, 4, 5. There is 6 here. There is no 6 here. 6 is the second. After 6, there is 7 here. There is 7 here. 8, 8, then 9 and 10. Now this is P union Q prime. If you look very closely now, you will discover that it is this member of P union Q prime that you need to add to P union Q to get the universal set. That means P union Q prime is the universal set minus P union Q. Universal set minus P union Q. And what is P union Q? All these circles. So universal set minus P union Q is shading all these sides and avoiding P union Q. Have you got the idea? So what we are going to shade is going to be, let this be our Venn diagram representing what we have in the question. Where we have this to be P, and we have this to be Q. Now, P union Q prime is universal set minus P union Q. The whole universal set minus P union Q. So we are going to shade the whole of this side. And avoid shading P union Q. Shade all this area, avoid P union Q. So this is P union Q prime, represented in Venn diagram. That is question number 8. We are going to clean up this and do question number B. Question number B is what we want to do now. It says we should shed P prime union Q prime. Just as I said, you have to resemble or forge a universal set, P set and Q set, work out whatever you are needed to shade in your Venn diagram so that you get the idea of what you should shade. Remember, in question number A, we used integers from 0 to 10. We used P to be prime numbers, and we use Q to be factors of 8. So that's also what we're going to use now. So our universal set is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our universal set. So our set P are prime numbers. And our prime numbers are 2, 3, 5, and 7. Now our set Q is factors of 8. This is prime numbers. This is integers from 0 to 10. Then factors of 8 are 1, 2, 4, and 8. So these are factors of 8, those numbers that can divide 8 without a remainder. Factors of 8. Now, we are required to shed P prime union Q prime. First of all, let's find P prime. You know that P prime are those numbers you can find in the universal set that you cannot find in the P sets. Those members of the universal set that are not found in P sets are called P prime. So let's check. 0, 1 is found here. It is not found here. So 0, 1 is first, then 2, 3. That's 4 here, there's no 4 here, so we have 4. That's 5, that's 5. That's 6, there's no 6 here, so we have 6. That's 7, that's 7. Then 8, 9, 10. So these are P prime. So let's find Q prime before we can find P prime union Q prime. So let's find Q prime. Those members of the universal that are not found in Q are Q prime. Let's check them. There's 1, there's 1, there's 0, there's no 0 here. It starts from 0. There's 1, there's 1, 2. There's 3 here, there's no 3 here. So 3 is among it. 3. That's 4, that's 4. 5, 6 is not here. So write down 5 and 6. 7 also is a member because there's no 7 in Q. 8 is here, 8 is here, then 9 and 10. Now this is Q prime. Now P prime union Q prime. P prime union Q prime. Members of P prime and members of Q prime. 0, 1. 0, 1. 3, 4. 3, 4. 5, 6. 5, 6. 7, 8. 7, 8. 9, 10. 9, 10. So these are members of P prime union Q prime. Now, check the relationship or the differences between P prime union Q prime and the universal set. That is where you get the idea of what you are going to shade in that Venn diagram. Like now we have 0, 1, there is no 2 here, but there is 2 here. They have 3, 4, 5, 6, 7, 8, 9, 10. So it is only 2 that is in the universal set, but not found in P prime union Q prime. Then what is that 2? Go to the relationship between P and Q. You find out that P and Q has that 2 that you're looking for here as P intersection Q. So the idea is giving you now is that since P prime union Q prime doesn't have 2, it does not have 2, and 2 is P intersection Q. That means if you come to the Venn diagram, avoid P intersection Q. It's a very simple thing. Now, draw your Venn diagram, shade everything avoiding P intersection Q. So let this be a resemblance of our Venn diagram, where you have set P here and set Q here. All right, so since we are to avoid P intersection Q, that means we are going to shade the whole of this avoiding. This is where we have P intersection Q. So shade everything, avoid P intersection Q. It is only P intersection Q that you avoid shading. So that is your P prime union Q prime. And that has brought us to the end of part B. So we're going to clean up again and do part C. By the time we finish all, you'll be able to know how to shade your Venn diagrams. Now let's do question C. Question C said we should shade P intersection Q prime. Our universal sets we have chosen to be integers from 0 to 10. Or 5, 6, 7, 8, 9, 10. Then we chose our P be prime numbers, and the prime numbers are 2, 3, 5, and 7. We also shows our Q set to be factors of 8, and we had them to be 1, 2, 4, and 8. Prime numbers. Factors of 8. These are integers from 0 to 10, our universal set. Now, let's find P intersection Q before we can find P intersection Q prime. First of all, let's find P intersection Q. P intersection Q are members of P that are also members of Q. So let's check. We can see that it is only 2 that is a member of P and also a member of Q. So P intersection Q is 2. Now let's find P intersection Q prime. Now P intersection Q prime are those members of the universal set that are not found in P intersection Q. So just remove 2 from the universal set and write down the remaining ones. So we have 0, 1, 3, 4, 5, 6, 7, 8, 9, 10. So if you look at P intersection Q prime, you find out that it is only 2 that you cannot find there that you can find in the universal set. Only 2. And it is that 2 that is P intersection Q. So if you want to shade your Venn diagram, you are going to avoid P intersection Q. What this is showing us is that P intersection Q prime is the same thing as P prime union Q prime, because you will shade and avoid P intersection Q in both cases. So our Venn diagram is going to take this shape now. We are going to shade everything but avoiding P intersection Q. This is our P. And this is our Q. So we are going to shade everything apart from P intersection Q. Shade all apart from P intersection Q. And it is this circle that is P intersection Q. So this is our P intersection Q prime. Exactly what we shaded in P intersection Q prime now was what we shaded in B part of the equation, which was P prime union Q prime. That shows us that P prime union Q prime is the same thing as P intersection Q prime. This is equal to this, and that has brought us to the end of question part C. We'll clean up again and do question part D now. Now let's do question number D. Question number D says we should shade P prime intersection Q prime. Our universal sets are integers from 0 to 10. Remember, we are the one that assumed this. And when you are trying to assume, look at the nature of the Venn diagram. Venn diagram has the universal. It has two sets. And it has P intersection Q. It has the intersection of the two sets. So whatever assumption you are making, make sure there will be provision for universal sets, provision for the other two sets, and there must be intersection in the two sets you are choosing. And that was why we chose Q to be prime numbers, which gave us 1 is not a prime number, 2, 3, 5, and 7. Now we chose P to be factors of 8, because 2 is going to be part of factors of 8, as we have P intersection Q. That was why we chose factors of 8. We had it to be 2, 4, and 8. Sorry, 1, 2, 4, and 8. 1 is also a factor of 8. 1 can divide 8 without a remainder. 1, 2, 4, and 8. So these are prime numbers. These are factors of 8. Now, let's find P prime. P prime are going to be members of the universal set that are not found in P. So let's check. 0 is one of it. That's 0 in the universal, no 0 in P. 1, 2, 3, 4. There is 5, 6, 7 here. There is no 5, 6, 7 here. So we have 5, 6, 7. There is 8 here. There is 8 here. So we have 9, 10. 9 and 10. So this is P prime. Now let's find the element of Q prime before we find P prime intersection Q prime. Q prime are members of the universal set sorry, that are not found in Q elements or Q sets. So let's check. We have 1, 0 and 1 is in the universal but not found in Q. So we have 0, 1. That is 2, that is 3. That is 4 here, no 4 here. So the next is 4. That is 5, that is 5. That is 6 here, that is no 6 here. So the next is 6. That is 7, that is 7. So we have 8, 9, 10. 8, 9, 10. So these are the members of Q prime. Now, the real thing the question is asking after P prime intersection Q prime. P prime intersection Q prime. Those members of P prime that are also members of Q prime. So let's check. We have 0, we have 6, we have 9, and we have 10. Members of P prime that are also members of Q prime. Let's check again. 0, no 5 here, no 1, no 4, 6, no 7 here, no 8 here, 9 and 10. We are correct. Now, you have discovered P prime intersection Q prime. Now go to the universal set P and set Q, and find what is significant about this P prime intersection Q prime. If you look at, now we have 1, 2, 3, 4, 5, 7, 8. So if you add 0, so what this means is that P prime intersection Q prime are those numbers that completes P union Q. The numbers that complete P union Q to universal set. If you join P union Q, those numbers that if you add these ones, it will make up the universal set. Because the universal set is 0, 1, there is 1 here, 2, there is 2 here, 3, there is 3 here, 4, there is 4 here, 5, there is 5 here, 6. So there is no 6 here, there is no 6 here, but you can find 6 here. 7, there is 7 here, 8, there is 8 here. 9, you cannot find 9 here or here, but you can find it here. And then 10, you cannot find 10 here. So P prime intersection Q prime completes Q union P to get the universal set. So if we should look for P union Q, let's find the members. Members of P union Q are 1, 2, 3, 4, 5, 7, 8. 1, 2, 3, 4, 5, 7, 8. Let's confirm it. 1, 2, 3, 4, 5, 7, 8. We are correct. So if you look closely now, if you add 0 here, add 6 here, then add 9 and 10, you will get the universal set. You can find out now that what you're going to do is you're going to shade everywhere in the universal set, but don't shade P union Q. Universal set minus P union Q is P prime intersection Q prime. So you're going to shade everywhere avoiding P union Q, which is all these places. Avoid shading it, but shade all these other sides. If we do so, you discover that we will be shading the same thing like when we shaded question number A. That means P union Q prime is the same thing as P prime intersection Q prime. So if this is our Venn diagram now, and this is our P, this is our Q. So we shade everywhere and avoid P union Q. P union Q is inside here, so we're going to shade all this area. Avoid P union Q. So this is your P prime intersection Q prime. From this now, if you rewind your DVD, you discover that what we shaded here now is exactly what we shaded in a question. That means P union Q, P union Q prime is same thing as P prime intersection Q prime. That's what it means. And this has brought us to the end of question number D. We are going to clean up again and do question part E.